Consider the color red. It's used for warning signs because it's bold and attention-grabbing, right? However, in terms of physics, red is actually the least active color in the visible spectrum. It bends the least, fights less, and scatters minimally. Today, we're going to explore how the universe often deceives us and how curiosity serves as our ultimate lens for insight. Imagine waking tomorrow, looking at the sky, and seeing nothing but utter blackness, although the sun is shining. This is precisely what astronauts experience in space, where no atmosphere scatters light. The stunning blue sky we view daily is merely an elaborate optical illusion. Let's uncover how our eyesight and the world deceive us constantly. In 1666, Isaac Newton found himself in a dark room. He drilled a small hole in a shutter, allowing sunlight to pass through glass, and unexpectedly uncovered the rainbow's secret. His discovery did not come from following a textbook. It emerged from his playful curiosity with shadows. What if the solutions to your biggest dilemmas are right in front of you? 1. The human eye and power of accommodation. The human eye functions similarly to a camera, directing light to the retina, a light-sensitive screen. Light enters through a transparent outer layer known as the cornea. The iris manages the pupil size, which controls light intake. Power of accommodation. The eye lens's ability to change curvature using ciliary muscles to adjust focus. O. Distant objects. Ciliary muscles relax, the lens thins, and focal length increases. O. Nearby objects. Ciliary muscles contract, the lens thickens, and focal length decreases. Vision limits. A normal eye can see clearly from 25 centimeters, least distance of distinct vision, to infinity. Light bulb. For instance, when you glance up from reading a book near your lap to spot an airplane, your ciliary muscles quickly relax, flattening the lens so the plane remains in sharp focus. Just as our eyes employ accommodation to focus on near and distant objects, our minds must adapt similarly. Staying in our comfort zone narrows our mental focus. Genuine curiosity compels our brains to extend their focal length, enabling us to comprehend a broader view. 2. Defects of vision and their correction. When the eye loses its accommodation power, vision becomes unclear. The text discusses 3 primary refractive defects. A. Myopia, nearsightedness. The issue. An individual sees nearby objects clearly but struggles with distant ones, as images focus in front of the retina. This occurs due to excessive lens curvature or an elongated eyeball. Solution. A concave lens of suitable power. Example. A student seated at the back of the classroom unable to read the blackboard clearly. B. Hypermetropia, farsightedness. The issue. An individual sees distant objects clearly, while nearby ones appear blurry, as images focus behind the retina. The near point exceeds 25 centimeters due to a long focal length or a small eyeball. Solution. A convex lens of appropriate power. Example. An adult needing to hold a newspaper at arm's length to read comfortably. C. Presbyopia. The issue. An age-related condition where the eye gradually loses its accommodation power due to weakened ciliary muscles and lens hardening. Solution. Bifocal lenses, concave at the top for distance and convex at the bottom for reading. Think of a problem you're currently facing as a beam of white light. It appears solid and uniform. However, when you filter this problem through the prism of curiosity, it separates into distinct components, like the colors of the rainbow. You begin to recognize individual aspects: red, blue, violet. Suddenly, a complex issue transforms into a spectrum of beautiful, manageable solutions. 3. Refraction and dispersion through a prism. Unlike a rectangular glass slab where the emerging rays remain parallel to the incident rays, a triangular prism is angle of the prism, causing significant light bending. Angle of deviation, angle D, the angle formed between the incident ray and the emergent ray. Dispersion, the separation of white light into its 7 colors, VIBGYOR. This occurs because different light colors travel at varying speeds in glass, bending at different angles. Red bends the least, while violet bends the most. Recombination. Sir Isaac Newton showed that white light consists of 7 colors by aligning an inverted prism with a right side up prism, transforming the dispersed spectrum back to white light. Light bulb example, rainbows. A rainbow results from natural dispersion. Tiny raindrops act as microscopic prisms, refracting incoming sunlight, reflecting it internally, and finally refracting it as it exits toward your eye. 4. Atmospheric refraction. Earth's atmosphere consists of layers with fluctuating temperatures and densities, which affects refractive indices, causing light to bend. Twinkling of stars. Starlight navigates unstable atmospheric layers, and because the star is a distant point source, its light's shifting path causes the star's apparent brightness and position to flutter. Planets do not twinkle since they are closer and appear as large sources that average out the flickering. Advanced sunrise and delayed sunset. We see the sun 2 minutes before it actually rises and 2 minutes after it sets due to atmospheric bending of sunlight toward our eyes. 5. Scattering of light and the Tyndall effect. When light encounters tiny suspended particles, like smoke, dust, or air molecules, its path becomes visible due to diffuse reflection from these particles. Particle size rule. Extremely fine particles scatter short wavelengths, like blue light, more effectively, while larger particles scatter longer wavelengths, like red light. Very large particles scatter all wavelengths evenly, resulting in white light. Everyday phenomena. Tyndall effect example. Witnessing a visible beam of light cutting through a dark forest canopy or entering a smoke-filled room via a small opening. Why the sky is blue. Air molecules are smaller than visible wavelengths, and red light's wavelength is about 1.8 times larger than blue light. Therefore, the atmosphere scatters blue light strongly, illuminating the sky. An astronaut sees a dark sky due to the absence of atmosphere. Why danger signals are red. Red light has a long wavelength and is scattered the least by fog or smoke, making it visible over longer distances. The world is brimming with discoveries waiting for you, but you need the right approach to notice them. If this video has clarified your vision today, show your support by liking, sharing, and subscribing to the channel. Let me know what content you wish to see next. Comment below with specific topics or questions for me to explore. In our next chapter, we will investigate how technology imitates nature. Activate notifications to be the first to see it.